Hi, everybody. I'm Shmuela Jacobs. I'm really happy to be here in iJS. This is my second time, and I love this conference. And I hope you love it too. I'm talking today about progressive web applications and a few tips of how to make this happen using Angular, and not only Angular. How many of you work with Angular? Okay, so those of you who don't, so what do you use? React? Who uses React? Vue? Backend only? PHP? Okay, so those of you who don't use Angular, please give it a try. It's really, really great. I love it, of course. But still, a lot of the things that I'm going to say here are relevant to any web applications, no matter what the framework is. So just a few words about myself. I'm a front-end developer. Like you can see, I love Angular. I'm focused on Angular in the past few years. I'm a trainer, a consultant, a developer. What else? GD, Google Developer Expert. And I am the founder of NG Girls. That's workshops too. Oh, I have stickers. So make sure you take some cool stickers of NG Girls later on. We do mainly workshops, but also other stuff for women to get them involved into programming with Angular. And next one, and we actually have 3 in the same day in Krakow, Hamburg, and Seattle. That's in Saturday. So that's really, really awesome. This is a picture from one of the last events that we had in NG Talks in Ukraine in August. This is another picture from there. We had a lot of fun. And you can reach me on email, Twitter, and so on. Okay. So, why should we care about progressive web applications? Well, we have many reasons to care about it. So this is a graph showing the number of mobile devices from which we surf the internet, from which we open applications, web applications or other applications, as opposed to using the internet from a desktop. So originally, we usually used the desktops, our computers, laptops, and so on, because this was a device strong enough to connect to the internet, to run browsers, and you remember our phones back, I don't know, before the year 2000. It didn't have a lot of ability to connect to the internet, to surf on the internet. And then the mobile phones became more and more stronger, and they have more memory, and data plans became much more efficient and cheaper for us to use, and we are connected to the web almost all the time on the mobile devices. So we had this turning point somewhere just before 2014, where we just had exactly the same number, and now we have more mobile phones using the web more than on a desktop. So this is really important. We want to make our applications, our web applications, also if it's just a regular website, we want to make it work well on these small devices that every one of us has on us all the time. Another thing that we should care about, Google announced that they will rate the applications and the websites according to their performance, according to their speed when you search for something on mobile. Why? Because it is important. You don't want a user on a mobile to wait too long for your application to load. When it takes too much time for an application to load, it's not just a bad user experience. It also shows that there are some problems in the background. The data that you send to the application, to the device, is too big. So data usage here is an important factor. If we still, some users still have plans that are data related. So whether they pay for a certain amount of data in a big, which will come in a great speed, and then the speed will be reduced. Or some plans just you pay per megabyte or gigabyte. So you don't want to overload the application, the mobile phone, with data, because it might consume too much. Also, the more data you send, the harder the phone works. So this is related to battery consumption. So the battery might really be consumed too fast for your users, and they will not want to use your applications. Okay. So these are really things that you have to take into factor when you design and create your web applications. A few more stats here. Well, so there was a survey, and upon a lot of mobile sites, and they saw that the average load time for mobile sites is 8.66 seconds, which is a lot. Do you know how much is does a user expect it to be, and how much patience do our users have? 3 seconds. Yeah. So if this is the average, then it means there are a lot of websites that are way more than 3 seconds, which is not really great. So we need to think about it. So here, the 3 seconds, we will lose more than half of our users, potential users, if the page takes more than 3 seconds to load. So, and it costs a lot of money. So every second delay in a web page time, it's we see it in conversion rate. So 7% reduction in conversion, fewer page views, and reduction in customer satisfaction. We can actually see how the users don't want to use our website or our web applications if it's slower. So these are the 3 major factors that are the application's performance usually depends on. So the file size, the size of the files that we send to the device. So the bigger the file is, the longer it takes to load. So we can think about how to reduce the file size, how to split files into smaller files and load only the necessary ones in the beginning, in the start, and load the other ones as the application is already running. The number of server requests. So how many requests we make to the server. So again, if we have less files to send, then it's better. So how can we both split our application to smaller files and also reduce the number of server requests? One thing that we can do is cache our files. So this means that the user has to, of course, first load the whole website from the internet, but then the second time, the files will be loaded from the cache. And the order in which elements are loaded. Sometimes the page is constructed in such a way that it takes a long time for one element to load, for example, an image, and it blocks everything that you have after it. And so the user waits for nothing. So maybe you can load everything else and let the image load in the background. Also some scripts. If you want to load scripts that are not necessary exactly for the first millisecond that the page loads, then load them afterwards. First load the whole page, the HTML, and only then load the scripts. So this is also something that can block. Okay, so let's talk further about progressive web application. What does it mean? Progressive web application. So first of all, it's an application, meaning it is sort of a program running on the web. But that's the second that we'll get to this in a moment. There's user interaction. It gets data from the server, and you can do stuff with it. Okay, so there's interaction. And we said it's a web application, so it runs on the browser and it is connected to the web. So all the communication to the server is, of course, done through the web. And the most important thing here is that it's progressive. So what does it mean that it's progressive? Okay. So we look at our mobile phones, and we see a lot of abilities and a lot of restrictions also. And we want to make our applications compliant to all these abilities and restrictions. But we don't want to force it, meaning if you run this application on a regular browser on a computer and you might not have all these abilities, then the application should still work. So progressive mean that we make enhancements, but only if these enhancements are really available for us to use. And the application will work also without them. So mobile phones have introduced a lot of things that we enjoy very much when we use them. So first of all, we have all the additional, how do you call it, gadgets that you have, like a camera, and you have the GPS that can give us the geolocation, and Bluetooth, and sensors of many kinds. If you remember, in the beginning of time, first computers didn't have a camera, and a lot of them don't have GPS built into them or Bluetooth, but we're starting to have this also in our computers. So not all of the abilities that we have in a phone, but some of them. So it is also still related to computers. But in our web applications, we are able now to access these devices, these features. We have the phone that we can make phone calls right from our application. Even if it runs on the web, the browser is connected to the phone. It will open the phone application. We get notifications on our phone. We get these push notifications, whether our application is open or not, whether our phone is in sleep mode or not. Well, of course, not if it's shut off. Notifications help us be more involved in the application. So I'm also talking about native applications, what we're using here. So if there's something new that we want to know about, if there's a new way to engage with the application, if there's something important to know, we can get a notification, and this brings us back to the application. So there's user engagement there. We shouldn't forget touch. we use mostly, unless you use BlackBerry, I think, if it still exists. We use mostly touch on our phones. So the applications have to be compatible to touch. We install applications on our phone. So this means we have an icon that we can press. So if we're looking for something, we also have a search on the phone. Most of the times we can search for the application, or we can just scroll and see all the icons and then choose the icon that we want, and it will open the application. And we can search our application in the App Store. If we're looking for something specific, then there's a specific place for that to look for the application. So a lot of things that we enjoy in our mobile phones and in these technologies, and also some things that we have to consider when we create applications, write applications for the mobile phones. We need to think about security, because we don't want someone malicious to know, for example, our geolocation all the time. Or get other data, maybe get access to our camera or our photos. We need to consider slow connectivity. So not everywhere we have this strong Wi-Fi or a strong signal. And in a lot of places, even really the places that you would consider very modern and advanced, a lot of places have slow connectivity. So I have friends, for example, in the United States, where they're not in the big cities, not in New York or California, or Los Angeles or San Francisco, but they have a more quiet life in a village, and they suffer from a really low connectivity of the internet, both in mobile data and in Wi-Fi. Right? The infrastructure is just not strong enough, not robust enough for the internet there. And of course, sometimes our target audience will be also countries that don't have the ability of a fast connectivity, a fast internet connection. So I mentioned before data usage and how it affects both the data and the battery usage. We need to consider offline mode, because sometimes we don't only have no connectivity, slow connectivity, but we don't have connectivity at all. So this happens for many of us, usually when we fly somewhere, when we go up on the plane, and of course there's no connection there. But it happens also in other cases where we just go on a field trip, and we really need some information and we don't get it, or we want to use some applications. So luckily the camera always works, and we can take really nice photos of the nature that we have around us. The application that I'm going to show you, the demo application, is actually inspired by one of these use cases, and I'll tell you more about it soon. So we talked about battery and also CPU. The CPU is not as strong as many computers, even though this small device, this very small computer, is for most of the devices that we have today is stronger and has more capabilities than the first spaceship that we sent to the moon. But still, we make our applications more and more complex, and we have to consider the CPU of our device, that it's not a really super powerful computer most of the times. We need to consider small screen also. So maybe we don't want to show all the data that we will show on a large screen. If we have very big graphs, for example, maybe we will want to reduce them or just skip them in the web applications or in any native mobile application. And we have to also consider touch, which sometimes limits us when we don't have the mouse, which is more accurate maybe, and we don't have a very convenient keyboard. So these are the things that came with the mobile devices, which are, like I said, some of them are really advantages, and some are things that we have to consider when developing our applications. When we're talking about web applications that run on computers, so like I said, many of the features of them that we have in mobile phones, we can use them also in our computers now. So when we develop our web applications, we can already make them use these features and make them more rich for all our users. So most of the laptops today already have camera, and if they don't, then they allow you to attach a camera through USB. Geolocation also, even if there's no GPS, then the computer knows where you are if you allow it, using the Wi-Fi connections that you have around you, because a lot of the Wi-Fi connections are listed in Google per location. We can use Bluetooth. We have now web Bluetooth. We have some sensors. We can use the phone with the phone application that we install on our computer. We can get notifications now. The browsers have implemented service workers that run in the background, and we're going to talk a little bit more about service workers. They run in the background even when the browser doesn't seem to be present on the screen when it's shut off, and you can actually get notifications from the servers of the applications to tell you that there's something happening. You probably have already seen this a lot, and I think it's overused sometimes. When you just enter a website, you still don't know what this website is doing, what it's all about, and it immediately tells you, do you want to get notifications from this website? What do you feel about this, right? So this can be annoying, but you can control when this, again, this is also a sort of notification when this question appears to the user. So please use that. Don't give it to the user right away. Wait until the user interacts a little bit, and then tell the user, hey, we can turn on the notification service. Would you like that? Are you interested in our information when even if you're not surfing our site? Some laptops already have also touch, but maybe we want to consider it, maybe not, because there are laptops that we can use also the mouse and the keyboard. We can maybe use icons. Some of the operating systems already allow us to kind of install web applications and have an icon for them, but usually we just use the browser's favorites or something like that. And usually we don't need an app store to look for applications. We just do a search on the internet, on Google, for example. On the other side, things that we need to consider when we're developing for mobile phones are also really beneficial when we use them also for our desktop users. So security is always a good thing, all right? like I said, slow connectivity is something that happens not only for phones, but in some areas in the world. Usually data usage is not something that we worry about, but maybe we do. But anyway, if we have slow connectivity, then again, sending less data will be better for the performance, for getting the first view of the application. Offline is also something that you may support. So, for example, I'm working a lot with Google Drive, and it's really helpful for me when I can use it also when I don't have Wi-Fi. I can edit my documents, and then once there's Wi-Fi, the documents are synchronized with the cloud, and I know that everything is saved. So think about your strategy of how you save your data locally, and when does it sync, and what do you do if there are any if someone else has used the same document and it has to somehow merge them, but you have to think about it for your application. Battery is, well, it's good always to think about battery, but it's less painful than mobile. CPU, small screen, and touch are things that are less relevant for our desktops. And on top of that, we also have a few good things that come from the web desktop world, which are also available now for web applications on the mobile. Web applications are linkable, meaning you can just share a link with someone and they will get this application. You don't have to tell them to search this on the web store and so on. You can share a link, and not only a link to the application, but also to a certain inner state in the application. So they can get precisely to the same state, to the same view with the same data that you want to show them. And there's no installation needed, because once you get the application to the browser, it is actually then installed. It runs the JavaScript, and this means that the application is sort of installed on the browser right now. And if you're using cache, then all these files will be also saved in your computer for a faster load. Okay, so when we talk about progressive web application, there are three characteristics that are the main ones that we usually refer to: reliable, fast, and engaging. These are the three pillars of progressive web applications. And we can talk a lot about them, and also go deeper into what does it mean, what characteristic will help us with reliable and with fast and so on. A really good talk about this is given by Christian Haleman. He's been giving talks about progressive web applications in several occasions. This is specifically one that I've seen in person in NG Poland. I think it was, or in JS Poland, actually, a year and a half ago. It was very relevant then. It's still relevant today. He gives a lot of examples of what to do and what not to do, and what to consider when you try to progressify your applications. So please look for it, and it's a really great talk. But we're not going to go any deeper into the characteristics. We'll talk about our application and how we can help it be more progressive, how we can use the tools that Angular gives us to quickly make it more progressive. So our application is written in Angular with the Angular CLI. Is there anyone not familiar with Angular CLI here? Okay, so just a few words about that. It's a command line interface tool that generates Angular applications for us with everything that we need in the application. It generates one main component in one main module, and it gives everything that we need inside. So with one command, we can serve it to the browser and start working on it. With one command, we can build it for production. We can run tests. Every component and every service and everything that we want to create with one simple command, it creates the boilerplate for us, including test files. And lately, there's been even more advancements there, where it started using schematics, meaning that you can write also code that modifies and add things to the application according to your needs. So we'll see that, for example, when we use Angular Material, which is a library. So when we install Angular Material using the CLI, then it not only installs it in NPM and adds it in this library, but it also modifies our project, our code, to load it in the right places and to do the adjustments, to load the default style from Material. And it just helps us start using it more quickly. So a really great tool, this Angular CLI. I'm using Angular Material in the application because it gives me components that have great design and great UX, and it also helps me with making it mobile friendly. To test it for how progressive it is, we can't test it on the local host. We need to use HTTP server for that. We can't test it on just serving it locally. And I'm deploying the application using NowSH, which is a really, really simple way to deploy, and there's a free plan, of course. If you want to deploy things really easily that, of course, don't need tons of configurations, then really check this out. This is the application. So, like I told you, my inspiration here was nature and the trips that I like to do in the nature, in distant places. And imagine that you're going with your friends out to the field, and after a long walk during the day, you prepare your campsite and your bonfire, and take out the guitars, wait for the food to be ready, and start singing your favorite songs. But then you can't remember the lyrics, right? So you take your mobile phones and let's search for the lyrics of this song. But oops, no data, no mobile connection, because you're in the middle of nowhere. So if you have this application installed on your mobile phone, and it's a web application, and you've already looked for the songs that you like, then they will be cached, and you will be able to just open them on your phone. I'm using here wait a minute. I'm using a third-party API that gives the lyrics for the song that I request. Is giving the name of the performer and the name of the song, and it searches for the lyrics. And how do we test whether this application is progressive enough, and how do we test its performance and so on. There's a really great tool called Lighthouse. It is already integrated in Chrome in its DevTools. So you probably already have it, but if you want, you can also install it via NPM and use it without opening your application on Chrome, and it will test your application. So the first version of my application was not so great at all. So there are a few good things that we see here, that accessibility and best practices in SEO. This is because I'm using Angular material, which gives us accessibility, for example, out of the box. So I don't need to try too hard to add it. And I'm using an Angular application with Angular CLI, so there are lots of best practices there and the SEO. But in performance and progressive web app, it's really not great at all. So I actually have this first version of the application over here, and you can see that it looks okay on the desktop, and it loads songs pretty fast, but that's because we have good Wi-Fi connection here. I can do stuff, we can search for song and so on, that's really cool, but that's not what it's about. Now, if I'm going to switch to mobile view, not this kind of mobile, let's say Galaxy, okay? Then you see that the menu of the songs takes almost all of the space. There's no way that I can close it, so all the lyrics are pushed to the side, and this is bad, right? We can't use the application like this, right? And I'm not going to, well, maybe I will show you. I will run Lighthouse here. So in the audits, let's make it a bit bigger. In the audits tab here, you find Lighthouse, and you can choose what you want to test. I'll just keep it as is, run audits. So you see the whole process. It simulates slow connection and offline, and it simulates even without me putting this on this mobile view. It simulates how it looks in the mobile, and yeah, well, already finished. And it gives us also not only the metrics, but also some tips of what we can do. So text is invisible while web fonts are loading. So what can we do with that? Leverage the font display CSS feature and so on. So a lot of tips that you can actually learn from here. Okay. I'm not going to go deep in this because there's so much that we can discuss just from what we get on Lighthouse. But you can do this by yourselves. You can test not only your own applications, but any application, anything that you can find on the web. Okay. So we want to make it my goal today. Well, of course, this can be even more than that. But my goal is to make it responsive, fast, offline, and app-like. So let's start with responsive. Like I said, I'm using Angular material, so this is how I added it to the project. So like I said, instead of doing npm install and then doing by myself all the modifications for the code, I'm just running ng-add Angular material, and it already gives me everything and puts for example, loads the animations module in the main Angular module, and like whatever it needs to do, all the instructions that they have on the website, how to add Angular material to your application. They do it by, it's done automatically here. The only thing that's not done automatically is adding Hammer.js, which helps us with mobile gestures. So you have to add it by yourself and import it just in the main file. Now, I want to make this app responsive, but in a certain way. So we talked about having this menu collapsible for mobile view, but it's also maybe a good thing to have it collapsible also for a desktop view if you want. But I want to know if I'm in a small screen in a mobile view, I want the default to have this menu collapsed, so I can see the initial content, which is actually adding a song. And if I'm in a desktop, then I want to see the as a default in the first load, I want to see the list of songs to see that this is an option. Okay, so a different view for a different screen size. So here I implemented it. You see that I added this toggle button. Okay, so this, if it's loaded here on the desktop, then you see that we can see the lyrics list. And if I switch to, let's put it again in Galaxy, okay, and reload it, okay, if I load it here, then initially it is hidden, and I can open it. And also you can see that now we have a backdrop, and we can close this and so on. So if I click on one of the songs, then the menu is closed automatically. Okay, so only for mobile view. Angular material and the CDK, actually, the CDK is what stands behind the components, and you can use the CDK to build your own components with your own style, with best practices of how the components behave. So the CDK gives us the media matcher, which is a great way to help us know which device the application is running on, which screen size, to know it not from the style where we usually use media query, but from the JavaScript code part of our application, from the, well, it's not JavaScript, it's TypeScript, but never mind, from the controller and our services. So Media Matcher, this is a service that you inject, thank you, a service that you inject in the constructor, and then you ask to match some type. You pass it a query of the media that you're looking for. So for example, the max width, and it actually gives It gives us whether it's matched or not, but we can also add a listener to it to pass a function, a callback, for whenever this changes. So some things I want to be relevant only for the initial load, for example, whether the menu is open or closed. And then if I change the screen size, then I don't want it to change. If the menu is open, then it's open. But some things I want to change when the user changes the screen. So you know that we can change the screen, maybe split our screen in half when we're using the desktop. So I want some things to happen there. In this case, I think I added a listener here in this case of whether you close automatically the menu when you select a song. So this is really I think the best solution that we have in this case. It works really great, and it comes out of the box with Material. And like I said, you don't need to install Material for this. You can also just use the CDK layout library. Okay, so we made it responsive, and well, of course we attach. We look for we ask the media query what is the screen size. We then decide whether we want the side nav opened, for example, and what type of side nav we want, whether it has a backdrop or not. And then we use this in our template when we use our Material components, like opened, the default value of opened, and the mode, whether it's a push or backdrop or anything else. Okay, so we made it responsive. Next thing that we want to make it is fast. So there are several things that we can do to make our application faster. So the first thing is create an app shell. An app shell is the initial view which only needs HTML and CSS and is shipped in the first index HTML or other HTML file that we give to the user before all the scripts are shipped and loaded and run in the browser. So this way, the user will not have to wait a lot of time to get an initial view. Many times we wait for some script to run to show us something, but we can always decide on some initial view that the user will see, whether it's a view of the application as is that maybe is not still, doesn't do anything that the user can't really interact with, then the user will have to wait, but still there's something on the screen. Or another option is to give some kind of a loader. So we have a great tool coming from the Angular platform called Angular Universal, which is usually used for server-side rendering. But when we render the application for server-side, it means that we can get a rendered view in our file, in the bundle, without having to wait for the scripts to run. So we add Angular Universal, and the instructions for how to use it are in the Angular CLI stories. I will show you here. Okay, so in their wiki there are several usages for Angular CLI. So you need to have routing in your application. You can add it after you already started working on the application, because what Angular Universal will do, it will create a route for this initial page that you want to see. And there in this route, you can put whatever you want, for example, this loader, the spinner. And from this route, it will generate this static view. Okay. Okay. And so you run ng generate app shell. So it is designed for app shell with the abilities of the server-side rendering. It uses the same abilities. And then it creates another build which has this the index HTML as an app shell. Okay, and to test it, you just run it with the app shell, verify that it works. I'll show you the output. So Okay. So you have an output of an index HTML that took all the necessary style that it needs for the components that I show in this initial route. And it creates the whole view. Yeah, it's okay. Here's all the HTML part. Now it's minified, okay, because it's for production. So that's why it doesn't look so great. But you can see that it's full of all the elements that we need. So it has here the components that we have that we've made in the project, the Angular components, but it also has inside all the HTML components that the browser can render. Okay, now one thing that you want to be sure to notice is that, well, I already used this this index HTML that I've generated for the regular build. But when you build it for the first time with Universal, it doesn't minify all the bundles, although it does add it here. So you will find here scripts of runtime.js and polyfill.js and main.js, which is not what we need for the production. Maybe it's hard to see here. Yeah, so here in the last line, all the scripts will be not the minified scripts. So what I do, I configure it to generate this app shell, not in the same destination of the production bundles, in a different place. Then I remove all the script tags from here. And then I build regularly with ng build -- production. And also in the configuration, I tell it to take the index HTML from the result that we have from the universal build. And then it will add the relevant scripts and not the unminified scripts. But make sure that you remove the scripts initially. Okay. So I mention it here, change the output location and remove the script tags, and then use it in the regular build. Okay, I'm going to skip these code examples. Let me see if there's something that we have to maybe mention. Okay. That's what the Angular Universal adds to our project to actually work and generate this route and create this view. Okay, so our application now looks a lot better. The performance has jumped to 68, and it's now kind of orange and not red anymore. And it's also more because it fits mobile better and the performance is better. Then the progressive web app score is also higher. But we'll lose some points in the accessibility. We have to find out why, but we'll check this. We want to make our app work offline. So for this, I used IndexedDB to store the list of songs that we have. And I'm using a library called Dexy, which is a really simple library for simple usages of IndexedDB. But we'll talk more about offline in the next section, because also we want the lyrics themselves to be offline. And we'll talk also about AppLike. So what does it mean, AppLike? Installable. We can install the application. We we actually will have an icon for it that we can click on it, and then it will open, and we will not feel that it runs in the browser. So this is AppLike. So this is achieved by a simple file called manifest.json. And you have a lot of tools on the web that helps you configure this manifest. It helps you with the icons that you can use, with the splash screen, the color of the screen when the application loads. And when you use it on a browser for the first time, for example, then you can also configure the color of the toolbar of the address bar of the browser. So it's all using this simple file called manifest.json. And so I also mentioned there's more work for offline, caching the songs themselves, the lyrics themselves. And we achieve this using the service workers. So service workers are, like I mentioned before, they are just JavaScript files. You can have one service worker per application. And in the service worker, this is like something that you have that stands between your application and the network, so a proxy. So all the requests that you have go through this service worker. So you can cache things. You can tell it, okay, requests of this type that go to this server, to this domain, please cache them, and cache them for example, 30 days. And you can tell it, first try to fetch the request from the server, and only if you see that there's slow connection or no connection, then show the cache, or do it the other way around. Maybe you prefer to show what's cached and in the background load the newer version. Okay, so you can have different options there. Service workers also help us with notifications. So if you want to use push notifications, then it's also done with the service worker. In Angular, we have a great tool that adds both the service worker and the manifest. And you just run ng-add Angular PWA. And then you get the files, and you have to modify them a little bit. Okay, so you get not the service worker itself, but a config file where you already have some configuration for the things that the tool has seen in your application. It goes through your application and sees what assets it has, what resources, and adds them here as something that needs to be cached. But you also need to add to it configuration for outer resources, for the data and icons and stuff like that, and to decide whether it's going to be loaded like for freshness, like I described before, get me the latest data if you can, or for performance, give me first the cached version. Okay, and when you build the application, then Angular CLI knows that it needs to add the service worker. It will add the file itself, and it also adds the command in the main file to register the service worker without blocking the application itself. And the app manifest, you can see the result of the app manifest here, that it when the browser knows that there's a manifest, then it allows the user to install the application. There's kind of a pop-up. It uses the icons that you gave it, and it gives this whole colorful view. So it adds the basic manifest, and you still have to configure it with your own icons and colors, and the name of the application also that will be displayed. Okay, so I have a final version of the application here. Now, there are some more things to work on, but it generally looks good. And you can search for more songs. Let's add a new song. What song do you want to add? Okay, We Will Rock You by Queen. Oops, Queen. Yeah, not the perfect application still, but it's here. Take some time, and here we get the we get it, and we can add it to our list, and now we have it here. Okay. It's deployed, but with a hashed domain name. So you can check it out. Basta-pwa-ysbafea. Okay, if you want, just come later. Okay, you have to pay for a normal domain name. I'll run the audits here. It will not be perfect, but maybe in progressive web app it will get a good score, maybe. But I think it's not performant enough. There are more performance tips, but we're already we ran out of time. But I'll just mention them. So you will either ask me later or look for it, what you can do about this. So tree shaking, Fort Awesome, which is kind of tree shaking for your fonts, Cloudinary for reducing your images sizes and giving the users the image that they need according to their device, Flat Buffers for sending for skipping the serialization of JSONs. If you're sending a lot of JSON file data or very large JSON data, so Facebook, for example, uses it for all the posts that and comments that you load. And also things that you can do with Angular, the change detection strategy, do it on push instead of the default one. One-time binding, so make sure that if you only need to bind something to show something on load, so don't include it in the regular change detection, and use pipes, which also use memwise to help you with performance. A really great resource for anything about PWA, and especially in Angular, is this guy, Maxim Salnikov, and he's also a speaker in this conference. So if you still see him around, please talk to him, or just look for him on Twitter. And he also opened a Slack channel that is all about progressive web applications. Follow him on Twitter. And this is me. You can also send me an email or find me on Twitter. And let's see the score. Okay, so the performance is not so great. We still have to work on that. I have somewhere a bug, but at least the Progressive Web App got a perfect score of 100. So I hope you got to learn something new, to get some new ideas. Let me ask you, if you've learned something new in this session, please raise your hand. Okay, awesome. So then I'm happy. So thank you so much. I hope you enjoy this talk and this conference, and keep in touch. Thank you.